Girls, today we are going to talk about the plotting of graph. So we have to plot graphs. Now when you're taking a graph or when you're plotting a graph, you have to remember that you have to use a graph paper of the size of the practical file. Now when you've done that, then on the graph paper, which is, let us assume this is your graph paper, you will leave at least 1 or 2 centimeter on the left of the y-axis and below the x-axis. Leave at least 1, preferably 2. So you can do that. Once you have taken a graph paper and you have also remember, I'm so sorry I forgot, that you have to cut the margins. So the margins have to be cut when you're plotting a graph. Now your graph paper is ready, the margins are cut, you've drawn your axis. Above the graph, on the top of the graph, you will write down the aim of the experiment, followed by plot. So the plot, let's say we are talking about the recent experiment, then you will plot a graph of time of flow versus molar concentration, or concentration in molarity, or concentration divided by m, right? So you have so what will be your plot? So plot will be written as time of flow by second versus concentration. Please do not use any abbreviation. Sorry, I do not have too much space on my tab also, but you will understand this. So plot will be written as time of flow versus concentration by m. Now you will plot your graphs. The graphs have to be plotted using a scale. So the next thing that you have to mention is you have to mention the scale. So the scale is always written like this: x-axis, y-axis, and you used to write small divisions and big divisions, you will only write centimeters. So 1 centimeter is equal to, let's say you've taken concentration as 0.1, then you will write 1 centimeter is equal to 0.1 unit. You do not mention the unit. You only write 1 centimeter is equal to 0.1 unit. On the y-axis, similarly, you will write 1 centimeter is equal to 10 seconds. So please remember this, you have to keep in mind that you do not write seconds. You will write 1 centimeter is equal to 0.1 unit, 1 centimeter is equal to 10 unit. No seconds, no molarity, nothing. It always has to be units. Do not write small division, large divisions, anything like that. Always write 1 centimeter is equal to 0.1 unit, or 1 centimeter is equal to 1 unit, 1 centimeter is equal to 2 unit, whatever divisions you have taken, right? Now moving on to the second, here is the, so now that you have understood that you have to write aim, you have to write plot. Plot is y versus x-axis. You have to write scale. Now, because on the x-axis and y-axis, the legends I have written as time of flow divided by seconds, and I also wrote concentration divided by m. Now, Dr. Sheikh did explain to you that why we are using divided by s, but I am explaining once again. According to the latest IUPAC convention, you always plot graph against two numbers. Against two numbers. You do not plot a graph of a physical quantity against a physical quantity. You plot a graph of a number against a number. Also in the tables, you always show the relationship between two numbers. You do not show relationship between two physical quantities. Now, what do we mean by the term physical quantity? So, when I say physical quantity, what I mean is, let's say I am talking about volume. Now, volume, let's say I am writing as 10 centimeter cube. Now, this is a physical quantity whose measurement has been done in the units of centimeter cube, and the numeral associated with it is 10. So volume is equal to 10 centimeter cube. Now, if you had to plot a graph of volume versus time, let's say volume expansion you are plotting against time, and time, let's say you've taken time as 12 seconds. Now, volume is not related to time by any standards. So, according to the IUPAC, if you want to show a relationship between the volume and the time, you have to write like this: volume upon centimeter cube versus time upon second. So now this has also become a number and this has also become a number. I'm repeating. How have they become a number? You had volume equal to 10 centimeter cube. Now you want to plot a graph where 10 is there. So then you will write volume upon centimeter cube is become 10. And what was your time? Time t was equal to 12 seconds. So 12 seconds, right? Now you will write this as t by second, so 12. Now if you plot a graph or you make a table of volume upon centimeter cube versus time upon seconds, they are both becoming numerals. So 10 is related to 12. But if you write volume 10 centimeter cube and t equal to 12 seconds, then there is no relation according to the IUPAC. So the convention is you always write the physical quantity divided by the unit and express it as a number and then show a relationship in a table or in a graph. Please excuse my bad handwriting. This has to be excused. Okay. So I have explained to you. So let's say give me any value, Shivani. Let's say 15. Okay, eta, let's say, what was the eta of water? Eta of the water is, let's say, eta at 30 degrees centigrade of water is 0.74 into 10 to the power minus 3 Pascal seconds. Now, I want to plot a graph of eta versus time, right? Or eta versus concentration. Then what do? You do not plot a graph of this versus time in second. You divide eta by Pascal seconds and your quantity becomes 0.74 into 10 to the power minus 3. Now Dr. Sheikh did explain to you that because if you plot a graph of 0.74 into 10 to the power minus 3, it will be a complicated thing. So what do? Eta upon 10 to the power minus 3 Pascal seconds, and your quantity becomes a measurable quantity like 0.74. So now if you plot a graph and you have series of these values like 0.74, 0.64, 0.89, then you can plot a graph easily. If you had to plot a graph using 10 to the power minus 3, it was a complicated procedure. So always make sure that you divide your physical quantity by units, and if it has some exponential factor associated with it, then you also divide by that factor so that it becomes a quantity which is easily plottable on a graph paper, right? Okay. Now, another important point that we wanted to talk is that you always have to use a 12-inch scale. What happens is that when you use a 6-inch scale, then sometimes when you're plotting a graph, you use a scale and you plot a graph like this, and then your graph, because your scale finished, then you plot on the graph. So now to a teacher, this break is visible. Don't do that. Please draw a graph using a 12-inch scale on a full-scale graph paper so that it is a continuous lines. Please excuse my these wavy lines, straight lines, because I'm drawing it on the because I'm doing it on the tabs, therefore I'm not able to draw a line straight. Please make sure that you use a scale and you draw a straight line, and that means a straight line with no joints visible to a teacher, right? Always use a sharp pencil when you're working on a graph paper. right? So we've talked about this. Now let's talk about the graph that we were talking about. Now you've been asked to plot a graph of time of flow versus concentration, or eta solution versus concentration. So let's say you've been asked to plot. Now I'm not showing you the graph paper, I'm just showing you. So you've been asked to plot a graph of eta solution versus 10 to the power minus 3 Pascal second. Now I'm repeating, why have we divided by 10 to the power minus 3? So that the numbers are measurable in nature. If you write 10 to the power minus 3, it becomes very difficult for you to interpret. And then on the x-axis we have concentration of NaCl divided by m, right? Now let's say you got some values of concentration which are 0.2, 0.4, 0.6, 0.8 and so on, and 1.0. So on the x-axis you have taken 0. So you're actually, either you have taken 1 centimeter is equal to 0.2. I would prefer that you take 1 centimeter is equal to 0.1. Don't take 1 centimeter is equal to 0.2, because I think you are using a full scrape graph paper, so you can very easily use 1 centimeter is equal to 0.1. See how you draw. Please understand, graph plotting is also a art. Please excuse my bad handwriting on the tab. I'm repeating. Okay, so let's say you plotted these are your values for your concentration. Now you have to plot a graph of eta solution. Now what are the values? Let's say the values, because you are measuring it for a solution, the solution will not have a value which is less than water, because when you add a solute to a solvent, and it is a solvent which is going into the bulk of the solution, the viscosity values will increase. Now the value of viscosity for the water was 0.75 into 10 to the power 0.74 into 10 to the power minus 3 Pascal second. So values are going to be higher. So on the y-axis, please take an axis which is measurable. So let's say you take 0. I'm so sorry, my tab is very small and I'm writing the numbers to the right of the axis. But when you are plotting a graph, you will be plotting a graph in such a way that these numbers are to the left of your axis. Please understand. So, okay. So your first value, let's say, is 0.74. Then the second value is, let's say, 0.75. Either I use an eraser. Let me take an eraser and rub and show it to you, because I don't want you to make a mistake. Okay, let's do this. So I'm rubbing and making another one for all of you. Okay. So we are again plotting a graph. Let me take the values: 0.74, 0.75, 0.76, 0.77, and please do it beautifully. My handwriting is bad. I'm repeating. Please do not make the mistake that I am doing here. Okay. So eta solution upon 10 to the power minus 3 Pascal second, and you put an arrow. And similarly, you have here 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 and so on, versus concentration divided by m. So this is your graph. Okay. Now let's say your first value was 0.1 and you measured and you got the value as 0.75. Now I did talk to you that day about the fact that when you mark a dot, the dot has to be there, and then there is a circle. What is the circle telling you? It is telling you that there is certain amount of error at that point. Now if you make a too big a circle, let's say this is your point and you make a circle which is this big, then it shows that the amount of error in your observation is very large. If you make a circle which is too small, then you are saying that you are very, very accurate, which is not possible in your lab. So make a circle which is okay for you. I mean, you should decide which is an okay circle. This is an okay circle that looks okay to you. Now, let's say you plotted a graph. These are your values. So now you have to plot a graph. Now your graph does not pass through origin. It's a straight line graph with an intercept. Now let's say this is the intercept. Now what you normally do is you draw a solid line like this. No, you're not to draw a solid line. You are plotting a graph like this. Now this has to be extrapolated. So the extrapolation should always be done with a dotted line. Always remember, the extrapolation has always to be done with the dotted line. And you draw a best fit straight line, right? A best fit straight line is one which is passing through maximum number of points. And this is a trend line. Please understand, this is a trend line. So it is extendable to a point. I'm repeating here, you are to write aim on the top, then the plot, and then the scale to the right, where you write x-axis, you write y-axis, and what do you write on x-axis? 1 centimeter equal to 0.1 unit, and 1 centimeter is equal to 0.05 unit. Please understand. Okay. Now, you've seen when you were in schools, you used to put a zigzag mark. No, do not put any zigzag mark. You will always write like this. So this is 0 on the x-axis and 0.73 on the y-axis. So you will mention this point as 0 on the x and 0.73 on the y. Do not write it as 0, 0 because this is not an origin. Origin means 0, 0. Origin means 0, 0, and this is not an origin. It is 0 on the x-axis and 0.73 on the y-axis. So write 0, 0.73 as the point and you draw a line. Please understand, this has to be kept in mind. You will always write the aim, you will always write the plot, you will always write the scale. The scale has to be in the terms of unit, never in the terms of divisions. And then comes the last part of the graph, that is to find out the slope. Now suppose you were to find out the slope of this graph. Do not take observation points for your slope. Always take points which are not the observation points and then find out the slope. You know how the slope has to be calculated? Slope is equal to what? y2 minus y1 upon x2 minus x1. So take points, note down these points y values, note down these points x values, and then find out the slope. So with this, I think we have explained everything that has to be done about the graph. One last point I'm repeating is, please understand, your physical quantities are always expressed as a numeral with a unit. Numeral with a unit. But when you plot your graphs or you draw your tables, it has to be always between two numerals. So you always divide your physical quantity by the unit and express it as a numeral so that you can show the relationship on the graph and on the tables. So with this we wind up this class. Okay, so sorry, I forgot. Shivani ma'am is sitting with me. So also remember, please, on your axis you put arrows, because what it shows us that these graphs are extendable, right? These graphs are extendable and can be extrapolated. Also about the trend line, this trend line should always be, do not stop at the last point, always extend your straight lines. So with this we wind up today's class. I hope this is helpful for you. Bye-bye. Where is the capture? Still working. How do we stop?